This is Dr. Charles Parker, and you're listening to CoreBrain Journal. It's a place where I connect both fresh discoveries and interesting different perspectives from advanced mind science with the realities of real people and everyday life down on Main Street. Well, welcome aboard, folks. You know, we have such an interesting group of people, and I know I say that quite often, so bear with me, but we have a guy today. He will definitely roll your socks up and down. You really have to put a seatbelt on and listen to Ira Pastor from BioQuark, who's going to tell us about the evolution of biotechnology as it applies to how we understand the world and how these organisms in the world can teach us how we can better heal ourselves, live our lives, and improve what we're doing for each other. Ira, thank you so much for joining us. Really appreciate it.
Thanks so much for having me. This is a pleasure.
So he has a great CV here, and you're gonna, in a way, internally smirk a little bit at the CV because I myself have got this similar CV. We came from traditional backgrounds, and yet we're over here in this other area. One of the reasons we're in this other area, and the reason I enjoy talking to guys like Ira, men and women like Ira so much, is because he's taken a foundation of terrific classic traditional knowledge and said, look, we can do more if we look a little deeper. So Ira Pastor is the Chief Executive Officer of BioQuark Incorporated, and I'll have the www.bioquark.com, and I'll have it in the show notes. Over 30 years of experience across multiple sectors of the pharmaceutical industry, including pharmaceutical commercialization, biotech drug development, managed care, did I say that? Distribution, OTC, and retail over-the-counter, and retail for drugs. He served as a VP of the business development for a drug developmental company, which is Phytomedics, raised $40 million of private equity. So he has stood the test of time out there. He was also consummating over $50 million of licensing deals and bringing lead drug candidates from the discovery stage to phase 3 development. I mean, this guy has been seriously busy. Prior to that, he was employed by SmithKline Beecham Pharmaceuticals, worked in sales, marketing, and business strategy positions. Mr. Pastor has also served as the vice president of corporate development for the pharmacy benefit management company, Prescription Delivery Systems with Cigna Health. He's got an MBA from Temple University. You're from Philadelphia, buddy.
Absolutely.
I'll tell you, I worked at Albert Einstein. My adult residency with Albert Einstein, and I did my child at Hahnemann. I love Philly. Yeah, we're right up the street. And your BS in pharmacy at Rutgers University, board member of the Regeneration SAPI. You'll have to tell us about that. A clinical company focused on expedited translational therapeutic applications of regenerative and rejuvenative healthcare interventions. That is a mouthful, my friends. And the Reanima Project, a member of the Executive Council of the World Academy of Medical Science and a member of the World Economic Forum's Human Enhancement Council. We have so much to talk about, my friend. Who knows where to start? So let's tell us a little bit about how you went. I think the big question in people's mind when they hear this intro is how did he get from there to here? What was that transference of information? How did you actually leap over that?
Yeah, it was a factor of spending 30 years involved in an industry that, while very dynamic and exciting and fun place to be, at the end of the day, I had a hard time understanding how we could generate $1 trillion a year, spend $200 billion on new R&D, yet all of the major problems that continue to kill us, heart disease, cancer, Alzheimer's, diabetes, and so forth, we didn't have any answers for. And there I am, enjoying my time in the industry and saying, you know what? I'm watching these diseases take my grandparents, or take my parents, and now I have 3 beautiful children. And you know what? I want to try to do it the right way with this next part of my career for them. So that shifted me into what I'm doing now, which is really looking for answers that we haven't had yet.
Well, that is so interesting. I mean, I think what happens is you didn't quite say it this way, but that's the larger picture. But somewhere in there, you said this is not sufficient. I'm doing something that's helpful. but I'm staring the reality in the face that it just isn't adequate what I'm doing, and I need to learn more to do it more effectively. And that's where we're very similar, because the same thing was going on with me. I'm running around speaking for pharmaceutical companies, and right in my office, I'm not getting it right for reasons that aren't on the page. So I have no idea what I'm doing wrong. I have to just dig further in to see what's going on. So next step is, tell us a little bit about your most current project with BioQuark, or even maybe you can even start with BioQuark, how you came up with that name. I'm so fascinated by the name. I think it's so cool.
Yeah, absolutely. In the name, we were trying to get something that encompassed both the biologic side of the life sciences, at the same time, the physical, because, in today's reductionist era, we too often, we look at the minutia in terms of the genes and the proteins, but we forget that there's a major biophysical structure above the genes, whether they're the cell networks or the membrane potentials of organs or the viscoelastic properties of the intercellular fluids. There's much more going on there that basically defines who you and I are at the end of the day than just the genes. So we wanted to find a term that encapsulated both the biologic and the physical things that are going on. But, beyond that, BioQuark's story is basically about going back to nature. Most people are unaware that, the first 100 years of the traditional pharmaceutical industry was heavily based on the natural world, primarily from small molecular substances derived from the plant, bacteria, and fungal communities, which generated trillions of dollars of wealth for the pharmaceutical industry. However, most of the really smart people will tell you that we've really only scratched the surface of what sort of nature has put here. And when we talk about all of the wonderful species out there that, from a health and wellness perspective, are much further advanced than we are as humans, we realize we have a lot further to go. And when we talk about more advanced, we're talking about things like the amphibians that can replace lost or damaged organs and tissues that are identical to the original, including spinal cord, eyeball, heart. Even large segments of the brain can be entirely regenerated following a catastrophic injury. Simultaneously, there are many organisms out there that, for instance, cancer, it's not the killer as it is for us as humans. Many lower organisms get cancer and just, they shrug it off. They like to turn tumors back into normal tissues. Now, of course, at the long end of the spectrum, you have organisms on this planet that do not age. You have some that age in reverse, and you even have a few that die and come back to life. And needless to say, as you and I both know, we as humans are incapable of these abilities today. Yet they're out there staring us in our face. So we wanted to take a 21st century look at what we've studied for hundreds of years now from a phenomenological perspective and see what's really going on and how we can reawaken, let's say, some of these abilities, which we know genetically we should still have. So that is the core mission and what we're all about today.
So that's still a very big, it's so interesting when you're saying that. And then I'm thinking, okay, but the question for me, and I know the question for our listeners is, that is a noble undertaking, but let's take a next step into what would be the application of an example of what you might be investigating, even how you investigate it, and then look at the possible applications for that principle that you've uncovered.
Okay, let's stay on the topic then of the brain. Obviously, it's the major frontier, the major biologic frontier is still remaining for all of us. Whether we are talking about chronic degenerative diseases of the central nervous system, so your Alzheimer's, your Parkinson's, as an example, whether we're talking about traumatic brain injuries, or whether we're talking about the severe disorders of consciousness, persistent vegetative state, coma, these are all conditions that either have an underlying cellular degeneration or a cellular damage component to them. Now, we know from decades of research that there are many species, fish, amphibians, planarian worms, and so forth, whose brains can be destroyed, ravaged beyond anything that a human could ever experience, and the brains grow back. And they grow back in perfect structure and function as if it was a common wound to you and I. These are the type of applications that we are interested in realizing. They end primarily in low organisms in the amphibian kingdom. Mammals typically do not have these abilities. What we have been doing, what we've been studying, is the biologic events that occur following those damage events and figure out how, using biologic substances, proteins, peptides, microRNAs, sort of recapitulate what we see in low organisms, but in mammals, in research lab, and ultimately in humans. So we can think about the central nervous system and all those conditions, and also the spinal column. Obviously, the spinal column is something that you and I with a serious lesion, and we end up in a wheelchair for the rest of our lives, but the newt, the salamander, they can regrow perfect structure and function of the spinal cord in a matter of weeks and be perfectly happy. So these are the types of indications that we are looking at. And specifically what we're doing in our lab is studying what happens in low organisms and how we transfer that knowledge via biochemical, biophysical approaches to the rabbit, to the guinea pig, to the rat, and so forth.
That is so interesting. So without, obviously, I'm not asking you to reveal any corporate secrets, but give us an example of maybe an edge that you're engaged in that's showing some promise, if you will, please.
Yeah, no, that would clearly be in our spinal cord research. So this is an area that for the last decade or so is sort of thought to be, the stem cell would be the holy grail to this thing. But the stem cell only addresses one particular angle. A stem cell is good for generating new neurons. But to generate a new spinal cord, you have to do other things. First of all, you have to get rid of the scar tissue that is preventing new neurons from connecting appropriately. Secondarily to that, you have to make sure the neurons connect appropriately. You do not want signals, as you know, coming down to move a right arm, moving your left leg. And lastly, one of the factors that is not, as we talk about this higher level architecture that's above the genome, a spinal cord is a certain size and shape. You do not want it regenerating the size of a tree trunk or the size of a toothpick. It needs to be a certain shape and size to function appropriately. So not only are we focused on the cellular components of regeneration, a la the stem cell side of the business, but we are very interested in isolating the signals that normally would occur in a developing spinal cord. That say, a spinal cord goes here, it connects as such, it needs to stop growing at a certain point, it needs to make the right connections into the peripheral nervous system, and so forth. This is what we have been focused on doing. And so here is an example where we will studied for years what goes on in the newt and the salamander. And in our models, the rabbit, the guinea pig, the rat, so forth, we have been conducting lesion models and then ultimately treating animals, what we'll call cocktail, sort of a combinatorial therapy, as we say, of biologic factors that recapitulate these different dynamics. Reprogramming of cellular tissue, dissolving via histolytic response, dead necrotic tissues and extracellular matrix. And also there's a component of it, very interesting, a stimulation of the innate immune system, which at a very low level is pro-regenerative in these species. So these are the types of things that we are looking at. We are taking a decidedly different view than, say, Big Pharma, which, as we discussed earlier, loves, single magic bullets for this type of stuff. But I will tell you now, and this will be true today and 1,000 years from now, you will never be able to solve something like complex regeneration with a single magic bullet. Yeah. When you study nature, you never find that. So that's why we're taking these combinatorial approaches to dealing with the problem.
Isn't that so true? I mean, the complexity is intimidating to a lot of people. The human mind wants just give me a simple answer because I don't want to think too much. But a guy like you, you're actually dealing with, and this is whole systems. You're not just dealing with here's a thing. You have all the connections with these multiplicity of things. It's not just one thing, it's several things and all the connections with that multiplicity of things. And then the question is conducting the orchestra and making it sound good.
Exactly.
That sounds so very interesting. So have you had any actual clinical experience with the work that you're doing that would be over on the human level?
We have very recently begun some, what would be described as sort of phase 1A tolerability testing, primarily with partners outside of the United States in Asia and Latin America. Our U.S. program is still about 2.5 years out just because of the nature of that. But yes, we have, we're a U.S. company, but at the same time, it's 2018 and clearly it's a global system of medical research that we have. And so we're out there not just developing our U.S. program, but at the same time, we're on the road. And hey, if we can get to human experience 2 years earlier elsewhere, whether that's in Asia or the Middle East, what have you, we're going to be there too, because we have to move these interventions forward because they're critical to what's
So
happening.
then there are several issues that you're talking about, and not this is just me coming from a high level of innocence on the topic that you're
Mhm.
talking about, but it sounds like some of the issues that you're talking about have something to do with nutrition and the idea of balancing out what would build the system. I'm asking you really the question and then the other thing is this whole communication factor. Is that something that occurs within the cells as they talk to each other, sort of like the quorum sensing that goes on with the bugs that are forming biofilm and all that sort of thing?
I haven't heard that term quorum sensing in a while. I'm fascinated and thankful that you brought that up, because that is a wonderful example for those that don't know listening. That is sort of the integrated ability of single cell microbes to communicate as a group. And this is fascinating. I'm so happy you mentioned that
I
term.
love the topic, buddy. I'm telling you, it's just
But
neat.
but this is key, because what you're mentioning and the proxies in humans, namely the chemotaxis and the sort of tropic intracellular signaling, typically is studied in these organisms. As we study the regenerative dynamic, you see this, in essence, community effect occurring. But it's not something, this is sort of one of the mistakes that sort of the pure stem cell people make, is thinking, hey, we'll just throw these cells in and they'll form something new for us, when the real model, how a spinal cord, for instance, or a brain forms in the first place, is not by mixing together a billion cells, but by one cell communicating with another one that divides and so forth, and the intracellular communication that happens. So this is integral. Yes, you've hit it on the head, that we want to recapitulate a bottom-up development process to replace that component, as opposed to sort of a top-down, throw the cells in, don't worry about what is happening between the cells, and thinking that every cell is just going to form the new thing that you're interested in. That won't happen. That's basically wound healing. You'll get a nice sheet of scar tissue, but
Yeah,
nothing functional.
yeah.
So yeah, no, excellent analogy. Yes. And simultaneously, that, as you were mentioning, we don't focus as much on nutrition, but what we do focus on is what we'll say the larger biomechanical properties of the tissues that need to be maintained so that dynamics at the bottom can occur. So as we're talking about things like biomechanical forces, mechanotransduction, yes, I mean, you can't just rebuild a spinal cord without, thinking about the musculature and in the surrounding tissue, or once again, the viscoelastic properties of the extracellular fluids that will support this. So yes, this all comes into play, and I'm really happy that you brought that up, and it's a great analogy to sort of the systems thinking that needs to go into.
Well, your response is so interesting to me, because as you just talk about the complexity, it's so illuminating, and so each one of those little paths that you allude to sounds interesting in and of itself. The question, of course, and we wouldn't have time to begin to talk about it here, but how does a person begin to actually measure those things? Because that's really what it is. Because if you're going to make an impact on it, then you want to know before and after. You want to say, well, here's where it was, and here's what we did, and here's what it is. And that's overly simplified, but that measurement in that kind of subcellular, it's molecular measurement. It's not even cellular measurement. It's molecular physiology.
Right. And fortunately, the tools have gotten to a stage where, you can analyze down to the cell level, the different sort of transcriptional, using some of the terms now outside of my domain, but, transcriptional bursting between one cell that's sitting next to another, and how randomness is sort of like diluted when you have a community of cells all firing away at different levels, and how those contents of certain substances or morphogens and morphostatic substances equal out. It's really neat. And on top of it, and this gets back to sort of the quark side of our name, you begin to see, and it's a wonderful group up at Tufts University that we have some dynamic with over the years, that focuses on sort of the bioelectrical functions that's happening in the system, and how, patterning, growth, size, shape, it's not dictated in the genes. It's dictated in the higher sort of physiological forces, as you were just saying. So how they communicate between the level of these different hierarchies is another entirely fascinating area that most of the industry sort of thrown all that stuff away because it's too complicated to think of, where they think of, bioelectricity as being ancient or something. But no, it's all sort of feeding back into the the system as, a relevant component of what needs to happen so you can have the full regenerative or remodeling event.
That is definitely wild. So isn't Stephanie Seneff at Tufts, if I recall correctly? She does a lot of work on autism and glyphosate and all that sort of thing.
I'm familiar with the name. The group that I'm more familiar with is that of Mike Levin, who was one of the got the grant a couple of years ago from Paul Allen, and specifically focusing on sort of the bioelectric properties of tissue.
That is so completely interesting. So then tell us what all of us are interested in, problems and resolutions. So we've had a very large discussion about a lot of things. What would you say as an individual person studying this and thinking about it have been some impediments for you or your collective team that you really know that you have to surmount for that next level of growth and understanding? What would be some of the things that are just like, hey, we got to get this solved?
Well, the major impediment, and I don't think it's much of an impediment because I've spent my time and I know sort of the other side of the industry and I know the regulatory process from past experience.
Mm-hmm.
But the whole concept of bringing something that is not a traditional drug to a regulator. So, most regulators think of sort of small molecular synthetic substances, little white pills that you get at the local Rite Aid. But when we get into this area of more complex interventions, drugs, whatever they may be, are going to look differently. I mean, what we're developing, we call combinatorial biologics. The thing in the vial is not a single compound. We are developing mixtures of substances. And while mixtures of substances have had their day on the market, I mean, in terms of, low molecular weight heparins and conjugated estrogens and so forth, it's a rare area. I mean, drug companies typically don't do this. So, we have to surmount that, but that's not going to be impossible. We're beginning to see pockets of these new types of therapies raise their head around the industry. I mean, when you look at the area of the sort of the microbiome and the fact, there's companies now that are developing, in essence, what are living cocktails of bacteria as the therapeutic entity itself, we realize that we're at the right time. Things are changing. Regulators are beginning to think a little bit more outside the box than they had in the past. So we're comfortable with that. Of course, we still have to, at the end of the day, realize that Big Pharma is going to be our marketing partner. Once we spend our $1 billion on development, you still need to spend a lot more to market and sell things. So clearly, that's always an impediment, negotiating and so forth. But at the end of the day, Big Pharma needs us more than ever before.
They do, absolutely. They know they're against the wall.
Yeah, they're in bad shape.
They know that, and they've known it for a long time. That's one of the reasons they're backing off on their whole marketing strategy and everything. Because they don't even have there are so many people writing for medications now that have no idea what they're doing. I mean, when I was speaking for pharmaceutical companies, again, I wasn't selling drugs. I was saying, guys, here's how to use them correctly. And what happens is the dearth of any kind of communication is really compounding the situation for the pharmaceutical companies. And they haven't quite recognized that, I don't think, because then they cut back on everything, which is really the communication process.
Right. And
it wasn't, yes, it was a selling thing. I think some of the guys that were doing what I was doing were selling. And I think that then became a problem because, in fact, they weren't really sure what they were talking about. And they really thought, I'm going to be a good sales professional. But anyway, that whole communication process is so absolutely relevant because when you're talking even about the pharmaceutical companies making an investment, and you said marketing, that's what it is. Marketing is really not marketing. It's explaining how, what, why, and what the problems are and how it works correctly. And that is going to be complicated, and people need to invest in that because otherwise it's not going to go out there. There's no question about it.
Absolutely.
So what would you say the next step would be that you guys are interested in terms of, okay, this is our next big project? This is what we kind of have gathered together with, and this sounds a little bit like I might be getting into confidential material, but whatever you're comfortable with there, because following you along the track and walking along this path with you, I start to imagine, okay, well, here are the problems, and then what do we work on next? We talked a little bit about the problems, and you did a very excellent explanation on that. So then the next thing is, okay, where do we go next? What can we do that's maybe closer to immediacy and a future resolution?
Yeah, I mean, so at this point on the more, let's say, traditional front, we're biotech drug development 101 now. So we're in the pipeline in the sense that we've done a lot of the early non-human work. And it's really, we chose when we started the company to design ourselves as a biologics company, just because biologics have been around 100 years now, and there's a regulatory path. We didn't want to get involved in more exotic tools like gene and genetic engineering or complex tissue engineering, anything like that, which make for worse hurdles. So we're kind of sort of in the clear with regard to all that in terms of straightforward drug development. Where we are is really balancing indications and what it makes the most sense for us as a company to go after.
I got
Spend
you.
a lot of time preclinically looking at a range of models, but at the end of the day, you have to pull a trigger on one. And that's just the nature of the business.
Yep.
So we are very active in the CNS.
Yeah.
However, whether it's Alzheimer's or whether it's something rare, still is, being discussed internally.
Yes, I understand. Yeah.
As you know, that's the nature of the beast. One other area I just mentioned, because we this is something that we just recently disclosed, but speaking about the whole area of genetic engineering, we're not a genetic engineering company, but there is a really fascinating set of data that we've been exploring that's in the literature on how one's body naturally reverses genetic mutations. This whole area of somatic reversion, whereby a lot of people don't realize that when they have a sort of a genetic disease or a rare genetic disease, that typically not every cell in your body is affected. Due to sort of random reverse mutations and other events that can occur, you are in essence a mosaic of possibilities. And sort of this phenomena of revertant events that occur primarily in regenerative tissues is really fascinating to us, because it gets us thinking, as opposed to, genetically engineering somebody to express more of X, Y, or Z or correct the gene. If there's a way to use our technologies for regeneration and removal of unfit cells in comparison to more fit cells, this could be a very sort of nice alternative to some of these, $1.5 million, $2 million gene therapies that are being promoted now. So that's an interesting opportunity for us as well, alongside your more traditional chronic degenerative diseases.
So tell me this, how can we as listeners, because a lot of what you're talking about is pretty arcane, pretty far away from our daily experience. But I think it's so important for a guy like you to come and talk to us, because I'm an innocent, even though I'm a physician, I'm very much an innocent compared to where you guys are. And I know that many of our listeners are going to feel exactly the same way, like, oh my gosh. And I think the natural kind of emotional, if you will, reaction to a presentation like this, which is so interesting, is how can we help? Is there anything we could do? What would be helpful for you as a professional that we could participate in, do anything? I mean, because this sounds so absolutely relevant. I mean, that's kind of a hard question. I mean, but, because I don't know people, it's funny because I know in your position, people don't ask you if they can help you out, because I don't really know enough to help you out, but I just think it's a worthwhile question.
Yeah, I mean, for us, it's all about spreading the word, and whether that's about spreading the word to research institutions that someone might know about in XYZ country that is interested in ABC indications and partnering on research programs, whether it's connections with investors, connections with other investigators here in the US that are doing similar type of work that may want to study sort of combination protocols, as we can talk about, combining biologics with electrostimulation of the spinal cord, which is something we recently got involved in. We're open. We're not big pharma. We're a young, flexible company that is passionate about what we do, and we don't, we're pretty transparent. So people have ideas in terms of new research plans and other paths to go. We're open to hearing about them.
Well, that's great.
I'm shy.
What's going to happen is because you're so filled with great ideas, and what I'm going to do is when we cut off and we finish our conversation here, we'll talk a little bit aside. I just don't want to go public with it, but there's some other people I think that you could talk to. I think this is there are a number of people that I've interviewed that would love to talk to a guy like you, and I'm going to connect you with them. And I'll talk to you about that when we get off, because I think it would work for you, and I know it would work for them, because a lot of what you're talking about is really very parallel to a lot of things we talk with other people about. And if you guys get to know each other, it's one of the reasons to have a program like this, because put people on the same path together, who knows where that synergy will go.
Absolutely.
So what an interesting conversation, Ira Pastor with BioQuark. We are looking forward to look at your website and learning more about you. Do you have videos over there? Do you have any kind of learning modules over there?
Yeah, we have a lot of things that people can take advantage of in terms of videos and some papers and other interviews that I've done and some of the programs that we're involved in. So yeah, come and reach out. We're pretty easy to get in touch with. We're pretty open.
That's great. Well, we'll definitely send people over there, and I'm looking forward, and I'll see what there is there on a video. I may load a video right on the show notes. It's fun because then a person doesn't have to go far. I can just click right on it. We'll see what happens with that.
Absolutely.
So, Ira Pastor, thank you so much for coming on. If you take another big step, it's like, oh my gosh, I can't believe this happened, then just give me a call, because we'd love to have a guy like you back on. You're really right on the path, and it's just been fun taking a little walk with you this afternoon. I really appreciate it.
The pleasure's mine. Thank you so much for having me. This was a great talk.
Well, we'll do it again sometime.
Sure.
Thanks for listening to CoreBrain Journal. We're working every day behind the scenes to bring you reports that connect research benches with those street trenches. Here we share the complexity of mind science because, as you know, details really do matter. One of the most pervasive, misunderstood challenges is how commonplace medications, like those written for ADHD, are used so regularly without clear guidelines. If you think you'd like more specifics, take a minute to download my 2-page PDF packed with video links and references on the absolute essentials of how to start ADHD medications. They're easily available at CoreBrainJournal.com/start. Thanks for listening. Do connect and stay tuned. Together we can make a difference.